Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at the new wire sizing options that exist in Design Master Electrical for Revit 2.0. If you are attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497. And our email address is support@designmaster.biz. In the new release, we have added a number of options to improve our wire sizing. So I'm going to walk through all of the wire sizing options that exist in the software, all the settings that we have, and point out the ones that are new or improved or modified. The changes we've made hit the wire sizing in a couple different places, and rather than try to show you just the different changes, I'm going to show you everything with wire sizing in Revit today and highlight the stuff that's new. So in customization, first thing we're going to look at are the wire sizes themselves. And this is the list of wire sizes that are available in your project. By default, Design Master has aluminum wires and copper wires with default insulation settings for them. We have the sizes of the wire, and then for each wire size, you also need to provide Design Master with the wire and insulation area that's used for conduit fill, and then the size of the wire itself without the insulation, and that's used for upsizing ground wires. So for each type of wire, you need to provide those numbers. These are taken from NEC Table 5. Again, we provide copper and aluminum with these specific installations. If you have other types of wire or other installations, you would need to include those as well. It's just a matter of adding additional wire sizes here. Those are the wires that you have then available in your project. We also have a command that shows you the conduit sizes. And again, here we have all of the conduits that are available in your project. By default, Design Master includes an EMT, a PVC option, and then what we actually use for all of our wire sizing, a combined EMT PVC, where we're using EMT wire for 2-inch conduit and smaller, and then PVC for 2.5 and above. For the conduit sizes, you again have to provide the area. We use that for the conduit fill. And then we have a checkbox for whether that's a standard size or not. Most commonly, people will go to the 1/2 inch and they'll uncheck that. A lot of people don't like to use 1/2 inch conduit, so this would be one way to get rid of it. You can also delete it if you never want to have it. If you uncheck this, it's still available to be chosen as an option. It just won't size to it automatically. So your choice as to how you get rid of the 1/2 inch if you don't want to use it, or any of the other sizes, or if you want to add another odd size, you can add it here, but not size to it automatically. These labels, and for the wire sizing too, they're all customizable. So this is just a string of text. You can type in anything you want. So you'll see that for the default EMT PVC option, it's just using conduit for the label here. If you choose the actual EMT, we label it as EMT. And this is just what we've chosen for our default standards to make it clear that this is being using EMT conduit or also PVC conduit, so that's differentiated in the wire callout because they have different areas and then different fills. So you do need to differentiate that. It needs to be called out somewhere, and that's how we chose to do it. If you don't like that, you want to do something else, you can change all of that. And since I didn't mention it, you can do the same thing for the wire sizes as well. So these labels here are all customizable. You can adjust them however you want. If you don't want to use the way that we've documented, if you want to put the aluminum somewhere else. Mostly for the aluminum wire, we had to have some way, again, to differentiate between an aluminum and a copper wire. So our copper is just the wire size, and the assumption it's a copper wire. And then the aluminum, we added the AL so that it would be clear to the contractor that that was an aluminum wire for that specific feeder. The conduit sizes and the wire sizes then feed into the wire ampacities command. And this is where you have your actual configurations of wires. So the wire sizes, the conduit sizes are really just setting physical sizes and areas. This is where we get into a little bit more of the electrical settings for these. So looking at this bottom section, each of these rows is a configuration of wires for a specific breaker size. So we have here in the first column the breaker ampacity, and so for if it's using a breaker of that specific size, what kind of wire are we going to use? The next column is the wire ampacity at 30 degrees Celsius. This is a new column, so this is a new feature that we've added in 2.0. So this is the ampacity of the wire itself as opposed to the breaker or the overcurrent protection that you're using. And you'll notice that in some cases, the wire ampacity is going to be larger than the breaker ampacity, because basically you always want your wire bigger than your breaker. You don't want to have wires that can carry less current than your breaker. So they sometimes will be bigger or they'll match the breaker size. We're going to use this in some of the new derating calculations that I'll show you once we actually get into the places where we're choosing the wire size. So mostly you set this to the right value and then our software will use it for derating. The next column is also new, again used for derating wire based upon ambient temperature. It's the temperature rating of the conductor. So you can choose what the rating of that conductor is. By default, we're using 60-degree wire up to number 1, and then 75-degree wire for 1/0 and above. And you can change that if you want to have a different standard. So we have options for 60-degree, 75-degree, and 90-degree wire. The next column is the description. This is a text field that's purely for your benefit, so that in the UI, when you're selecting the wire size, you can tell the difference between the choices, because you can see we've got options here for the copper and aluminum wire. So you can tell the difference, because in some places we'll say 80 or 80 AL, and that way you can tell the difference between the two. So this doesn't show up on your drawings in your project anywhere. It's purely for the user interface in our software for telling the difference. For example, you could come in here and we could make a new wire size. We'll do 100. And say you wanted to have a wire size for 100 amps where you're actually using 90 degree. The temperature rating for your conductor is 90 degrees. So you could do 90 there, and we'll say 90. And so now we have a new option. We can say, okay, the one that has 90, that's where we're sizing it using 90-degree conductors rather than the 60-degree default. And then you adjust the other options along here to match. Next is the wire size. So this is the actual size of the conductor wires for this ampacity. This is a list, from that list that we created in the wire size. So you choose your option here, but you tell it which size wire you're going to use. We also have the ground wire size, both for a service ground and an equipment ground. Service ground is from NEC 250.102. That's by default when you connect to a utility or a transformer, we're going to give you a service ground. Everything else is going to use an equipment ground, and that's NEC 250.122. So the ground wire size depends a little bit on what you are connecting to, so we have two options there. The next option column is the number of parallel runs. So this is the number of sets of wires, conduits that you're using. So if you have multiple sets, that really comes into play in the larger wires. So for a 1,000 amp feeder, we're going to have 3 runs of 400 kcml wire. The wire ampacity is for a single run of wire. So the actual ampacity, we will multiply the parallel runs by the wire ampacity to get the total ampacity of that configuration. So this value, you just give the ampacity of a single run, and then our software will do the math for the whole configuration. After parallel runs, we have the X and the R, the reactance and resistance. These are from NEC table 9. And this is again for a single run of wire, and then we'll divide by the parallel runs if you have multiple runs. So this is for use in fault and voltage drop calculations. So obviously get those values to be the correct values from the NEC. And that depends on the wire type and then the type of conduit again. So if you have different configurations, you can add more configurations with different impedances as appropriate. Next column is the conduit type. This is where you can choose from those groups of conduits which one we're going to use for our automatic sizing. So by default, everything's using this EMT PVC combo choice. But if you always wanted to use EMT for a configuration, or always PVC, or this one doesn't have a wire conduit at all, you could just go in a cable tray or something. You could specify that here. And then when we're choosing the conduit, we're going to choose from those options. And we don't have a specific conduit size because the conduit size depends a little bit on whether it's got a single pole, so it's got a single run of wire, or it's a 3-pole circuit, so it's got 3 circuits. It has a neutral, if it has a ground, and what the size of everything is. So the conduit size will vary for a specific ampacity. So we're just saying, okay, use these conduits and figure out the one that works for a 40% fill. The last 3 columns are whether this is a standard ampacity to size to or not, and for each configuration, for each ampacity, which configuration is the default. So for this, this is all controlled by these sizing options up here. So we're in the copper option. That's a default with Design Master. So it's chosen all of the copper sizes to size to automatically, and you still can size to the aluminum, but by default, it's going to go to the copper. And if we go up to some of these smaller sizes, the 15 and the 25, we don't size to those automatically, except for equipment circuits. So for just a standard branch circuit or a standard feeder, you're not going to get a 25 amp, you'll get a 20 or a 30. But you can override that, and if you want to size your feeders to 25 amps or your branch circuits, you can do that. You can have multiple configurations of sizing options. So if we go and select the aluminum, this is, again, provided by default. You can add more. Here, it's going to use the aluminum sizes for all of the wires. And then we also have a copper and aluminum, where it's copper up through 1/0 wire, and then for number 1 wire, and then 1/0 and above, it's going to be aluminum wire. So you'll see that in the smaller sizes, we've chosen the conduit option, the copper option. And then down here in the larger wires, it switches over to using the aluminum sizes instead. You have a default that's going to be used within the whole project. And then a new option is that for a specific feeder, you can choose a different option for that feeder. So we'll take a look at that when we are actually looking at sizing our wires. So you can actually use these a little bit better than you were in the past. It used to be you had a single option and that was all that was ever used. Now you can actually use the different options within the same project a little bit better than before. So that's all of the customization options we have for wire sizing, conduit sizes, and then the wire ampacities. That's what you use to tell Design Master, this is how I'm going to size my wires. We then use all of that in the panel edit and the circuit edit for wire sizing. So I'll go to panel edit. I'm going to select this MDP panel. We scroll down, we've got the feeder section, and it has the wire size that's listed here, the whole call out with all of the wires. This is being controlled by the conductor size. And right now it says default. And so it's going to be using that copper sizing as the default option. And the size of the wire, the ampacity for default, is going to be based upon the trip. So you actually have to come up here to the overcurrent protection trip to figure out the size of the wire. And the overcurrent protection trip also has a default, so it's using the same as the main disconnect. So you bounce up to here, and we've got a bus size of 100 amps. There's no main disconnects, it's main lugs only, so it's a 100 amp feeder. So if we change the bus size here, we get a larger wire. So the wire size, you kind of have to bounce up until you have something that's overriding it. So if we come here, we could override, we could say, okay, I'm going to, for whatever reason, lock that at a 250 amp overcurrent protection. So it's a 200 amp panel, but it's a 250 amp breaker. So we're going to size the wire based on the 250 amps. I'm going to leave that as the default for now. So that's what happens when you size the conductor automatically. We also have the option, and this is a new option, to choose a specific sizing option. So you could say, okay, I want to use this and have this be a copper feeder, or I want to use my aluminum wire sizing, or I want to use that copper and aluminum wire sizing. So previously, if you wanted to use a different material, you had to come down and choose the specific wire size that matched the ampacity. And then if you changed, the panel size, you'd have to remember to come and change your conductor size also. It worked. It just required a little bit extra care on wires that you were sizing differently from your standard. Now you can say, okay, I know this is going to be aluminum, but you choose the size for me automatically. I don't have to remember to figure that out. So we can say, okay, just always have this be an aluminum wire. So we'll get the 250 kc mil wires. And then again, if we come in here and change this, move it to a 400 amp feeder, 400 amp panel, you'll get the 400 amp aluminum wire. You again also always have the option to choose a specific wire size. So we have the options here for where it sizes it automatically, and then you can come just say, I want it to be this specific option. And you'll see here in the 100 amp range, we have that new option that we added. So we've got the 100, 100 AL, and then the 190 that we added. So that's where that description shows up. It's just right here to differentiate between all of the options. It's not going to show up in the on the project at all. For the neutral, by default, the size of the neutral is the same as the phase wire. We can also set it to be double the phase wire. And when we do this, we are now going to actually derate the wire as well. The assumption is that if you're going with the double neutral, the neutrals are going to have or be current carrying neutrals. And when you have more than 4 current carrying wires, the NEC asks you to derate them so that we do that. So if we change this to a double phase, it'll go from 250 kc mil, and it's going to upsize it to a 350 kc mil aluminum wire. And so that's where the wire ampacity comes into play. We use that for the calculation for what that the new conductor size should be. You can also always choose a specific size for your neutral wire if you want to just say this is the size of the neutral for whatever purpose. The ground wire, we can size automatically. We can also size based upon the equipment ground or service ground. So if you say size automatically, what you're connected to will control the wire size. So this is a panel that's connected to a panel. So it's going to use the equipment ground. The switchboard here is connected to a transformer. So it's going to use the service ground instead. So the ground size changes depending on what you are connected to. So going back to that panel we were looking at. So again, you can change that, and then you can always set it to none if you don't have a ground wire, and you can set it to a specific value if you want to. The ground wire also changes if you upsize the conductor. So we are right now a 400 amp feeder, and we've got the number 2 ground. If I just change the panel size to say 600 amps, it goes to a number 1 ground. But if we upsize the wire, but not the panel, to a 600 amp wire, it goes to a 2-aught ground. The NEC has a requirement that if you're upsizing your conductors, you need to upsize your ground in proportion. So you actually end up with larger grounds when you're upsizing your wires for voltage drop purposes. And so we take that into account when you're upsizing just the wire with a specific value. For the conduit, we by default size automatically based upon 40% fill. You can override that with a specific conduit size if you want to as well. So you can tell us what size conduit you want to use. It will calculate the conduit fill. That's too small. The wires aren't even going to fit. That's obviously much bigger than it needs to be. So we do that calculation just so you know where you are. And we will let you exceed the 40% fill when you're choosing the conduit, because at that point, you're, anytime you're making a choice, we're letting you be the engineer at that point. We're not going to stop you from doing whatever you need to do, because there are times when you need to, go outside of what the software thinks is an appropriate value. And so we just allow you to do that, hoping that, you know what you're doing when you're overriding the software. The ambient temperature is a new field as well. So we use this for derating also. By default, actually within a project, you have a default value. So if I go into my project customization, project options, we have a default ambient temperature for the entire project. That's down here, currently set to 30 degrees. That's the default that you're going to get. You can override that as appropriate. If we change that ambient temperature, say this is actually up on the roof, we can override it to a different value, and then we are going to get, again, larger wires. So it's using that wire ampacity value to do the D rating and the temperature rating of the conductors as well. Older versions of the NEC had suggestions for how much to increase the ambient temperature depending on how far it is from the roof. The most recent one, they actually got rid of that because they were finding that it wasn't making as much of a difference as they thought it did. So if you, depending on which NEC you're using, if you are using one that requires you to still make that adjustment, you have to go look it up in the table yourself and type in what the appropriate ambient temperature is. Newer NECs aren't actually even requiring that. That's how you set your feeder size for a panel. For transformers, it's the same sort of thing. The only difference is that the overcurrent protection size, we size it to match the size of the transformer rather than the bus size, because transformers are different. So we use the transformer size, and that actually goes to a new option, which is the transformer overcurrent protection sizes, where for specific size of transformer and a specific voltage, you tell us what size overcurrent protection you want to use. We had a calculation for this, but not everyone was happy with that calculation. We tried to work with people to figure out, well, how could we calculate what the overcurrent protection size should be? And people were rounding in different places and using different assumptions and going different ways. And so, for a specific size transformer, we had 3 different answers that people used, all using various calculations. So we, at that point, said, well, we can't account for all of that with a calculation. We'll just do a lookup table, and you can always get the right value with the lookup table. It just requires a little bit more input. So we provide default values using what our sizing used to be with the lookup table, and then you can come in here and adjust this if you want to use different size overcurrent protection for your transformers. And use the defaults. You can always override that for a specific transformer as well. Circuits also work essentially the same way. You've got your conductor, which by default is going to go match the overcurrent protection size, and then all the same options for neutral, ground, conduit. The overcurrent protection, by default, if you haven't done anything else, is going to size to 125% of the load on that circuit. You do also have the option to go into the devices themselves and set some additional information. So if we go take a look at that cooling tower on that CTP circuit, if we run the instance edit command, we have the option here to set the overcurrent protection trip size based upon specific values. Basically, we've got the motor and motor compressor options included. So you can size it based on that, or you can say, let's just use this size breaker for this piece of equipment, and the same for the conductor size. You can size it based upon the motor or motor compressor values, or give it a specific wire size. And then when you do that, we will feed that into the circuit edit as appropriate. That is it for wire sizing in Design Master Electrical. So the new features are going to be the wire sizing options for a specific wire, where you can say it's going to be a copper or aluminum. The wire ampacity, separate from the breaker ampacity that we use for derating based on double neutral, and the ambient temperature. The rest of that's the new stuff. The rest of it hasn't changed, and that's how we do our wire sizing in our software. Are there any questions on wire sizing or any of the other features in the beta, or anything in the Revit software at all?
Hey, David, it's Brian at ME3.
Hey.
Yeah, appreciate all this customization. I just have two quick questions. Is this in the 11? I think the 11 just came out, right? Is that all within the 11? Okay, all right.
Yep.
Okay.
Yeah, all of this is current.
Okay, current. Okay. And then secondly, if I go to a custom overcurrent protection size, like a 500, Like sometimes we use 500 amps or 700 amps, which most people don't do, but we've got weird instances
Yep.
where we have. Are all the wire size things you just went through? They're pretty much right. There's no real changes, just a different. It's just a nod size from the 400, 600, 800 kind of deal, right?
Yeah. So you just in wire ampacities come down here. Actually, this one has a 500 by default. But yeah, so if you needed something, say you had something really weird, say you had a 550. Now you could come in here and do a 550. So now you've got your new 550 option. Maybe you don't check it as standard because you don't by default want a size to it.
Oh, I see. Okay.
But now it's an option that you can choose. Now, obviously, you want to get your wire sizes and whatnot right. We'll assume those are all correct. But then in panel edit, you can say, okay, I actually have a 550 amp breaker.
Okay.
And then you'll get the matching wire size.
Then you get a matching. Okay, good. All right. Just want to make sure there wasn't any nuance there that I was going to miss. Okay, good. Thank you.
Yep. Yeah, you're welcome. Now, the biggest nuance on that one, I would say, would be just when you create those odd sizes, don't check it as standard so that it's not being used.
It's not. Okay. Yeah, I see what you mean. Okay.
Yeah,
Perfect.
that would be the big difference that you'd want to take into account.
Exactly. Okay. Thank you.
Any other questions on wire sizing or anything with the software?
Hey, David, this is Pauline.
Hi.
I have a question. I mean, this will be for us the first time to update the software through Revit. So what is the best practice for that? I mean, right now we're in the middle of a huge project, but, we just want to make it right.
Yeah, so in terms of updating the software, there's really no trick to it other than just you download the installer and you run the latest version. For your project, all of the customization, so all of the project settings that you have, those are stored in the project. And once they are set in the project, we are not going to change them. So we might change what shows up in a new default project. So like all of our wire ampacities, we've added this new copper and aluminum, that's new. We are not going to add it or make any changes to an existing project. All of those settings are at this point yours for that project, and we won't touch them because if we did, we'd start messing with wire sizing for existing projects and bad things happen if you do that. So all of your customization stays the same. There's nothing that happens when you install the new version other than you just get the new features or the bug fixes.
But that doesn't imply that we can always use those customization new features from Design Master.
So when you upgrade from 1.4 from our old version to 2.0, we did add some values. We added this wire ampacity and the temperature rating. So we provide default conservative values that, again, aren't going to change anything because these only come into play if you then start using our derating features. Otherwise, all of your customization stays the same. If you do need to make changes to the customization, you'll want to use our import and export to transfer those between your projects because your projects can end up with different settings if you're starting to make changes on them.
Okay, got it. Thank you.
Yeah, you're welcome. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.